Welcome to day 4 of our problem solving unit. Today we'll look at age problems. Let's jump right in with an example. A father is now only 3 times as old as his son, but 8 years ago the father was 5 times as old as his son. Find their present age. Now we have two relationships here that give us a system we can solve. Let's start with a let statement. Let's go with f equals the father's age, and let's say b, since my s's look like 5s, b equals the son's age. Okay, now let's create two equations that show the two relationships. A father is now only 3 times as old as his son. So there's one equation for us. Father is 3 times as old as his son. F equals 3b. But 8 years ago, the father was 5 times as old as his son. Now this is the absolute key to these problems, setting up this type of relationship. If f and b are the father's and the son's age, we do f minus 8 and b minus 8 for their ages 8 years ago. So we would have a relationship like this. F minus 8 equals 5 times b minus 8. Because if you read the problem, 8 years ago, the father was 5 times as old as his son. Now you can see we have a system like we've solved before. We can substitute 3b for f, and that gives us this equation. 3b minus 8 equals 5 times b minus 8. The reason we can substitute like that is because f equals 3b. So we put 3b instead of f. Now you can see we have an equation with just one variable, b. And you guys can solve that equation. Let's do a little distribution first. 3b minus 8 equals 5b minus 40. Let's subtract 3b from both sides. Minus 3b minus 3b. We'll have negative 8 equals 2b minus 40. Let's add 40 to both sides. And we're going to get 32 equals 2b. Divide both sides by 2, and we're going to get 16 equals b. So if we go back to our let statements, it says that the son is 16. B was the son's age. So the son is 16, and then the father's age was 3 times the son's age, so the father's age would be 48. So we'd have f equals 48. Then we should check this. We should check this with the other statement. 8 years ago, the son would have been 8. So 8 years ago, the son would have been 8, and the father would have been 40, and that means the father would have been 5 times the son's age. So we know we've done it correctly. And so we finish with a sentence. The father is 48 years old, and the son is 16. Let's do another one. John is twice as old as Bill. In 5 years, the sum of their ages will be 34. Find their present ages. Okay, let's start with some let statements. These are pretty easy. J is John's age. And let's go with B for Bill's age. Okay. Now we set up two equations, and then we'll substitute into one of them and solve. So the two equations that show the relationship is John is twice as old as Bill. J equals 2b, twice as old as Bill. And in 5 years, the sum of their ages will be 34. So remember, this is the key part here. In 5 years, we would have J plus 5 and B plus 5 because they're 5 years older, and it says the sum of their ages, so put a sum, add them together, will be 34, equals 34. Alright, now we can substitute from one equation to the other and have an equation with just one variable in it to solve. Since J equals 2B, let's substitute that in instead of J. 2B plus 5 plus B plus 5 equals 34. Let's collect up some like terms. 3B plus 10 equals 34. Let's subtract 10 from both sides. 3B equals 24. Let's divide both sides by 3. B equals 8. Now we go back to our statements. This is why the statements are so helpful. B equals Bill's age. And we said John was twice Bill's age, so John would have to equal 16. And then let's check that. We say in 5 years the sum of their ages will be 34. And so 16 plus 5 is going to give us 21 for John. 8 plus 5 is going to give us 13 for Bill. 21 plus 13 does equal 34. We know we've done it right, and so we write a sentence answer. John is 16 and Bill is 8. And we've done it. Let's try another. You pause the video and try it. Write let statements, write two equations that express the relationships, and then substitute one equation into the other and solve that equation that's in one variable. A mother is 3 years less than 5 times as old as her daughter. If the sum of their ages is 39, find the age of each. So, the let statements come pretty easily. Let's go and let M equal the mother's age. And then let T equal the daughter's age. Okay, now we need two equations that express the two relationships. So mother is, remember M is equals, M equals, mother is 3 years less than 5 times as old as her daughter. So 5 times as old as her daughter would be 5D. 3 years less minus 3. The sum of their ages is 39. So we would have M plus D equals 39. Find the ages. Well, here's where we can substitute. We said that M was 5D minus 3, so let's substitute it in instead of M. 5D minus 3 plus D equals 39. Collect up like terms. 6D minus 3 equals 39. I would add 3 to both sides. 6D equals 42. It's looking good. Now I divide both sides by 6. D equals 7. So we said the daughter's age was 7. And we said the mom's age was 5 times the daughter's, 3 less than 5 times the daughter's age. So that might take some figuring. We have the mom's age equal 5 times the daughter's age minus 3. 35 minus 3 is 32. Now we could check the sum of the two of them was 39, and 32 plus 7 does equal 39. And we know we've done it correctly. We write a sentence answer. mother's age is 32, and the daughter's age is 7. Now you try the worksheet.